So thank you everybody for attending. My name is Louis Normandin. I'm the COO of Wild Capture. We appreciate everybody who's here for the XR enablement track today, and we hope that you guys have a good time. The next guest coming up is Jonathan Kyle and Sven Brunner, the co-founder. The co-founder and CEO of Sphere, and they're here today to talk about spanning time and space with mixed reality and digital twins. Thank you, everybody. Please welcome Jonathan Kyle. Thank you so much.
Thank you. Thank you very much. Good afternoon. Hi, everyone. My name is Jonathan Kyle. I lead global business development and go-to-market strategy for digital twins at AWS. And digital twins is a key focus strategic area at AWS that we're looking to grow. And one of the key enablers that we see is with the VR, AR, XR community, such as yourself. So today I'll be joined by my colleague Sven Brunner, co-founder and CEO of Sphere, and we'll be talking about spanning time and space with mixed reality digital twins. Now, digital twins is a kind of loaded topic. Like, how many people can know what a digital twin is by the raise of hands? Okay, and I probably have like just as many different definitions of what that is, right? So I think the biggest problem that we've been facing in the industry is the hype that we're kind of coming down on, and we have to thank marketing for that the last 6 or so years. But we're really trying to look at how do we scale these in production. But just really quick, to kind of level set and make sure we're all on the same page on what we mean by a digital twin. At AWS, a digital twin is made up of 4 key aspects. The first is you have a physical system or process. It has to just be something in the real world. The second is a virtual representation, what we call a response model. There's different types of modeling techniques that you can use. You can do physics-based modeling. You can do data analytics. We're increasingly seeing more like hybrid modeling. The main takeaway, though, is you give it an input with either sensor data or some information, and it provides an output, a response. The third key aspect is the connectivity between the two. But really, most importantly, there has to be a purpose to the digital twin. It has to be a business outcome. And Sven will kind of spend more time on that in the latter half of this presentation on what those will look like. But there has to be a purpose and a business decision that can come from it. Now, again, digital twin is not a new topic. It's been around for a long time. Dr. Michael Greaves at University of Michigan is credited at first applying it to manufacturing way back in 2002. NASA's John Vickers in 2010 actually coined the term digital twin. So we've been living with this concept for over 2 decades now. And I think the real question is, why haven't we seen this more at scale in production with real use cases? And at AWS, we feel like the reason is it's because not until the 2020s, not until now, that we see the confluence of really 4, maybe 5 mega trends that are coming together in kind of a synergistic way. The first is, if you look at sensors. So look at how are we capturing the data to begin with. The cost of sensors from 2010 to now has dropped by about 50%, and that's a trend that's continuing. So what was once cost prohibitive is now a commodity. It's no longer an excuse to sensorize assets, so there's going to be more and more sensors collecting more and more data. If you look at another trend closely aligned with it, it's like, okay, now how do you transmit that data? If you look at wireless connectivity as a proxy, in 2010, we all had 3G phones, a few hundred kilobits per second. Later in 2010, we migrated to 4G, so we're looking at 10 megabits per second, 100 megabits per second. Now we all have 5G, and most of us have 5G access, so 10 gigabits per second. So that's a 10,000-fold increase in just about 10 years, which is fantastic. And in terms of availability, you look at oil and gas, for instance, like offshore rigs and things like that. You have satellite connectivity with Kuiper and SpaceX's Starlink. So with both availability and the transmission speed, there's really no excuse we can transmit any amount of data. So those first 2 megatrends are all about getting the data, but data is not information and information is not knowledge. The key of the digital twin is to convert that data into information, into knowledge, so that we can allow our customers to make better business decisions. So okay, what do you do? How do you do that, right? So with the modeling aspect, so we're looking at HPC, high performance computing. The cost of chips has dropped dramatically, and then we're connecting them together in the cloud at massive scale. And that is driving a lot of this, we think this increase in adoption of digital twins. And the final driver, I will say, is the VR, AR, mixed reality capabilities as well. We're seeing a lot of customers in many different industrial verticals adopting these capabilities for many different use cases, such as augmented worker and things like that. Now, this definition of digital twin doesn't really fit neatly. There really is no one definition of digital twin. So you're seeing a lot of different leveling frameworks. This is ours. It's a 1 through 4. If you scan that QR code, that'll take you to a 5 or 6 part blog that'll go through kind of an overview of digital twins and how we view each of these levels. We took inspiration from the autonomous vehicle space with their different levels of autonomy. And I'll just go really quickly of what these are, but if you want to read these blogs, I highly encourage it to get a more depth definition of these. But this is not to say that one level is better than the other or that you have to go through and progress through all of them. It's just to help better categorize the different use cases and flavors of digital twin. So first, L1 is a purely descriptive digital twin. These are things like CAD models, 3D geometry, simulation models, CAE, kind of your traditional engineering CAE environments. That gives you a huge benefit, right? So now you're moving things from the real world to a virtual world, so it's easier to move bits than atoms. You can do things like design optimization, but there's no connectivity back to that real world. You're still in this completely virtual environment. Level 2, this is when we get to connecting the IoT data to the real world. So you're understanding the state of what's happening right now with my asset or process. So things like 2D panes of glass or dashboards for like factories, even augmented workers. They're wearing a headset, walking the factory floor. They can contextualize different information. They can connect to someone, for help or assistance, or bring up maintenance logs, things like that. L3 and L4, though, is when we start to look at understanding the behavior of an asset or process. And this is where techniques like computer modeling come into play. The main difference between L3 and L4, though, L3 has this implicit assumption that future behavior will be similar to past behavior. So this is very important in things like machine learning and data analytics, where you have a training set, you've trained a model, and you're hoping that once you deploy it into the real world, what it sees and experiences is roughly the same of what it's been trained on. Ultimately, though, we know that's not true. Things change, the environment changes, assets degrade, and that's where we get to in level 4, where there's no assumption anymore. And what you're doing now is more probabilistic modeling, things like Bayesian estimation, and you're updating the model parameters in real time as data is coming in, and the model is changing and adapting to mirror what the asset is actually seeing. So in terms of like bridging and spanning time, this is what we mean by that. The L4 allows you to predict further into the future and have confidence, and ultimately let the customer have confidence in what they're seeing and what they're predicting. And I won't spend a lot of time here. This is explained more in the blogs, but in the orange, these are all the AWS services. There's quite a lot. But this just shows that no matter where you want to start in your digital twin journey or your customers, we have services and specialists that can help you all along that way. And with that, I'll hand it over to Sven, where he can talk more about Sphere and their XR platform and how they're spanning space and time with mixed reality digital twins. So, Sven?
Thank you very much, Jonathan. Hello, I'm Sven. I'm the CEO and co-founder of Sphere. And how we're going to talk about digital twin today is a little bit different than maybe what you've heard before. We're going to more focus on, you can almost think as the asset is now the human. Now I'm going to explain how that looks like and what we're doing with that concept, and also how it relates then to AWS and our partnership with them. So in general, I think what we can say, and I think probably most of you would agree with that, we're at an inflection point in a new work paradigm. We've gone through a pandemic where basically we had a fundamental shift in how people work and collaborate, from most people working in an office to hybrid or fully remote even. And there's some interesting facts around that. So for example, a study shows that at the moment, almost 60%, 92 million people in the US can work remotely. Doesn't mean they all do, but they have the ability to. Yet, 84% of executives say they actually prefer in-person meetings. Similarly, 88% of employers trying to incentivize people to go back into office. Maybe some of you have also been victim of that, especially also large tech companies trying to get the people back, right? Then on the other hand, 64% of workers would actually consider quitting if they had to go back full time, right? Maybe you can relate to these stats. But takeaways, there's a pretty big discrepancy between these numbers, what maybe companies want and what workers want. Basically what the result is, meetings are less productive than ever. You have a widening skill gap of people being now remote. They cannot really train people on site anymore as effectively as before. I think we can all speak to that too. There's a bit of camera fatigue, sitting in front of a computer all day and have to turn your camera on constantly. And always collaboration is always mostly limited to 2D spaces, right? You have a screen in front of you where you can do things which is nice for certain things, but not enough for others. And hybrid meetings, meaning like you have maybe people with you in the same room and people remotely, feel very, very awkward, very inefficient, doesn't really work well with the tools we have at disposal today. What that basically means is that the entire workforce, most companies face massive challenges, right? And basically the question we also try to answer and solve is, how do we basically generate the efficiency of in-person meetings and the feel or sense of presence of in-person meetings, even though you are not naturally or maybe always in the same physical space. So what is Sphere? Sphere is both our company and an XR solution. And it's basically an immersive collaboration solution that basically our pitch, you can think of it as, we try to eliminate both where you are, or it doesn't matter anymore where you are, and even what language you speak. And we'll get to that in a second. In general, the whole theme is to also empower humans to do more work, right? It goes a little bit against the whole, even though we're also very positive about that, the AI trend where it mostly tries to automate things. XR is always very nice about being empowering people, giving them superpowers, right? This is also something we're trying to do, right? Increase team engagement when you collaborate. More classical cases like reducing machine downtime with remote assistance and workflow guidance, what you're probably all very familiar with. Also improve employee training across distances. We'll get to that in a second. And of course, always with reducing travel, reducing carbon footprint, doing something for our planet as well. We're also, that's important to mention, we're a interoperable XR platform, meaning we support a wide range of headsets from like our friends here, Magic Leap, Lenovo, but also the Microsoft HoloLens, the Meta Quest Pro, alongside also more traditional computing platforms, iOS, Android tablets, and even PCs. We're also very flexible when it comes then to things like deployment models and how we integrate into other software, but more to that in a second. And we really see to solve this issue is really to kind of unlock a new level of collaboration that we believe has now, the time is right for that with the tools that are available at our disposal, and XR plays a center piece in that story. One thing is that we have developed are realistic avatars, and that you can really think of basically a digital twin of a human being, right? So the goal is obviously, or that's an interesting stat actually, that 93% of communication is nonverbal, meaning body language, how you look around, how you move around, which is not that easy to translate, definitely over a phone call, and sometimes not even over a video call, right? Because you only see like maybe half of your face, or in a dimly lit room or something like that. And basically what we try to do with our avatars, and we'll see a demo of that in a second, is basically to eliminate the need to be actually on site with someone, because the sense of presence that you get with the person or with the avatar in your room should actually almost be the same as if you were with that person in the same physical space, right? But they can be wherever they want in the world. And of course, that reduces cost, travel time goes down, you can collaborate much more efficiently and quicker. And let's quickly look at that in action. This is actually filmed on a Magic Leap 2 device, one of the devices we support. And let's see if the video plays. It does. That's good. Okay, so this case you can think of as basically let's say a design review, right? We're having here, I think this is the rocket that brought the James Webb Telescope into space. And you can see here that this is filmed from a first-person view, and we have this other colleague in the office who's basically interacting with the content as if they were in the same room, right? They can move around parts. We would also hear them. The headset where hears the other person. I can exactly see where they're looking at. We synchronize eye movement, blinking, hand movement, rotation of the head, of course the position and so on. You can see very precise hand tracking is also synchronized for the other user. And it's also important to mention all of that you can save. You can load it again afterwards. You can have as many participants as you want. Some are maybe in person, some are remote, and we support all these scenarios very seamlessly and to really make it easy to collaborate and work together, again, across borders, across time and space. Now, another important aspect or interesting aspect is actually live translation. Some people sometimes in the US forget that there's countries and people that don't speak English that well. For example, myself, I'm a German native speaker. I'm Swiss though, it's very important, but a German native speaker. And what we've developed also and integrated now into our software is live audio translation. So that means not just captions, not just subtitles, but actual audio translation. Meaning, let's say, take an example, let's say, again, German native speaker, me. Let's say I would call or talk to a colleague in Japan who's a Japanese native speaker. And let's say we wouldn't both be super proficient in English, and we would speak in our native language. So what would happen is I could speak in German, the other person could speak in Japanese, I would hear their live or their audio feed translated to German, so I hear a German audio, and they hear the Japanese audio from my language. So basically, we're not just eliminating the necessity to be in the same physical space, but you can also speak whatever language you want and to collaborate much more efficiently. And there's many, many languages we support. Basically, all the display languages that we have in our solution are all supported then for live translations. So there's a wide range of languages there. And obviously, I think we can all see how much that actually can improve cross-border collaboration, mostly, that you can more effectively work with colleagues all around the planet, have a sense of presence, and be able to talk to them in your own native language. We have actually a quick video of how that looks like. Actually, the sound doesn't come through, so it does.
例如，在跟中国供应商的合作过程中，双方都能更顺畅且无障碍地谈妥产品生产的预算与时间。
A live XR translation is a major improvement for customers working with their suppliers in countries like China. Now, each party can flawlessly understand one another. Less mistakes are made due to miscommunication, so products get to market on time and on budget.
And you can imagine that, of course, this is now just in a video, right, side by side, but this is how you can imagine a first person would speak in Mandarin in this example. We could also translate directly to English, and I would hear the English language feed and not the Mandarin one, because I don't speak Mandarin. The other part also that we're, and I said we're an improbable or an open platform, basically, is that we have the ability to directly integrate in your favorite conferencing tool. So actually, just next week, we're going to ship the first of those integrations, which is Teams, meaning that you can directly from your vanilla Teams client, without any modifications, directly dial into a Sphere session and the other way around. With all the feature sets available, meaning that basically every Teams user in a company can also use our software or at least get into a session of our product. More are to come. We're actually working on integrations with Zoom, with WebEx, Google Meet, and so on. But this is an enormous, or it's really, really important, especially for large organizations who have a large installed base of users that already use Teams, Zoom. I'm sure all of you use those tools as well. And you basically then have the ability to directly get into a Teams session, interact with these avatars and so on from your vanilla Teams and then in the future Zoom client and so on. Now, basically, how do we work together with AWS, which is a very, very close partner of ours, both on the go-to-market side, but also on the technology and development side. So first of all is our Sphere software is a cloud-based offering, runs on AWS, which is our basically public cloud tenant, which is scalable, and most of our customers are actually using, which live directly in the cloud. We also support, this is the SaaS multi-tenant one, but we also support private cloud, so we're pretty flexible. If you're an AWS customer and you want all of our software or servers deployed in your private cloud on your AWS tenant, this is also something we can do. We also have an enterprise-ready deployment, so we figured out all the firewall issues, data security, privacy, especially with real-time services. This is not so trivial, but it's something we really invested a lot in over the past few years and have really also made deployments in very, very restrictive corporate firewalls and so on. And all the services are containerized. You can easily deploy them. They're Dockerized. You can use a Kubernetes cluster and so on. So this is all taken care of. What we're also working together with AWS, we actually are integrating a variety of services. The one we just saw before is actually the live translation, which is in large parts also powered by AWS services. We work very closely with them to enable that, to basically the whole speech-to-text engines, translation, text-to-speech again, and so forth. We're also working on adjacent things, for example, Amazon Lookout for Vision, basically to enhance the workflow guidance experience, that basically with an intelligent way to see whether the steps you have been conducted were correct or not automatically by the machine. And of course also AWS TwinMaker, right, which is also, I'd say, a very more direct digital twin application where you basically are able to get live IoT data onto your headset while you walk through the factory floor. Is probably what most people would think of as a digital twin in XR, walking through a factory floor, look at the machine, and you get the live data feed from that machine. There's also an integration we did together with AWS. Now, very quickly to wrap up, maybe just 2 customer studies or stories that kind of show a little bit how our solution is applied. One is actually Micron. Micron is a US semiconductor company. Probably most of you know them. There's a good chance that if you have a laptop with memory in there that Micron produced it. They're a market leader there. And they basically have been using our solution for over 2 years now. And there's actually some pretty impressive ROI numbers that they measured. So for example, last year, they were able to save or reduce machine tooling downtime by more than 3,000 hours. By reduced machine downtime, again, they didn't have to fly in experts to fix the machine and so on. They were actually, by using our XR SOP or the workflow guidance scenario, we're able to increase machine availability by 1% to 2%, which maybe sounds low, but in semiconductor, literally every second counts, right? If the machine is down for even just a little bit, it costs them a lot of money. So there's for them, a really big improvement. And they're even using it for their construction cycle. Maybe you've heard of the whole CHIPS Act, and that now like a lot of them are building fabs here in the US again. They're also using our software for the planning process, basically placing, again, you can also see it as a digital twin application, basically placing the 3D models of the construction or the BIM model on the construction side to kind of see if it fits, for installation checks and so on and so on. And another story, which is actually one of my favorite ones that we support, is basically a project we're doing with the University Clinic of Heidelberg. It's more of a healthcare application. But basically what we're doing there, we're supporting those doctors to treat or diagnose potential victims of childhood violence. Meaning that the current model is basically this hospital clinic is responsible for a radius of around 400 miles of local doctors to support them in those cases. And at the moment, if a child comes in, could be in the middle of the night, and this local doctor usually doesn't have the expertise to make the call whether it's child abuse or not. It's a very sensitive call. You don't want to send the child back to their parents if it's actually being abused. And you obviously don't want to accuse someone of child abuse if it's just they were playing with their friends and fell and something like that. So usually what happens at the moment is that the expert from the university clinic needs to drive there. It could be in the middle of the night, 4-hour drive, inconvenient for everyone, the parents, the child, the local doctor, the expert, and so on. What they replaced that now is with our solution. So basically the local doctor is equipped with a headset. The patient comes in. They directly connect with the expert. This would be the expert view that you can see here. They see through the eyes of the person on site and can basically guide them through the examination, lend their knowledge. Similar case to what, let's say, Micron does on their machines, but here we do it on real-life patients, right? Which is, again, one of my favorite cases because it's not just something, usually we talk a lot about making money, and of course it's part of the business too, but it's also a very nice application to show that actually this technology and technology in general can actually do something good also and to really help people with their daily lives. That was it. Thank you very much. I think there is at the end this code to rate us how well we did, but thank you very much for your attention.